we are just going to be starting the 2-7 notes today. We're not going to finish them, so there's no new assignment or anything. But this is just going to help to make it when we come back on Monday that we can do a lot more practice on other sections, and then we'll wrap up 2-7 as well. But I figured with just the 45 minutes and me being gone, this was kind of the best way to use our time. So the first two examples are what we're going to cover. And you'll notice that we have these, well, in this case, one fraction in an equation, and this one maybe is a little more indicative to what we'll have, is where I've got fractions adding and subtracting, and they can equal, in this case, 0, but there could be another fraction over here. And we're going to look at how to solve these, what look like very complicated problems that actually are going to be very similar to something we have done before. So before I hop into how to do this, I do want to take a moment to show you that you already kind of have the strategy that we need back from PreCalc A. So PreCalc A maybe give you something like this. So I'm just going to make up some numbers here. Oops, that's supposed to be a 3 over 2 equals, I don't know, x plus 8 over 3x plus 8 over 3. Okay, and so you did something like this, and we had talked about that you've got, all of these fractions, and you've got all these denominators, and in PreCalc A, we only had constants in our denominators. We're going to add having x's in there, but like I said, the path of solving is very similar. And so what would happen here, or what we could do is, yes, we could get everything with a common denominator, but instead what we did was we multiplied by what that common denominator would have been, so that I could, what was called, clear my fractions. So here's what that process looked like as a reminder. So 6, 2, and 3, their common denominator would be 6. That's the least common multiple of those 3. And so I multiply my entire equation by 6. So I start by distributing here. I'm going to show you some steps. There was some shortcuts you could take in the middle, but only after we kind of got used to them. So we multiply by 6. This really is 6 over 1, so that this 6 on the bottom, nothing happens to it. Just the top gets multiplied by 6. The top in this case also gets multiplied by 6. We talked about not actually distributing, and you'll see why in a moment here. So plus 8 all over 3. So here's my distributing to every term on both sides, so that's still a balanced equation. Now the reason that that works, because you're like, well, you still have all these fractions. I do, but I now can do some division and simplify. So 6 over 6 is 1. 6 over 2 is 3. 6 over 3 is 2. And so now I don't have any fractions anymore. Now I'm just solving this. I would distribute, so minus 3x minus 9, make sure you distribute the negative. 6x plus 16. This would be, so if I add 2x over, that would take care of that. A little quick solving here. Minus 16, so I got negative 25 equals 8x, 5 by 8. So negative 25 eighths to be what your solution is. Okay, so this process is the exact same process we are going to do when we get these complicated ones. Is we are going to multiply by, what would be the common denominator to clear and do some canceling or dividing out with that denominator because of that, of using that common multiple. So let's go to your actual notes. Whoops, I got to go back a step forward and kind of write what we're doing. So the idea, again, is we are going to clear the fractions by multiplying by I'm going to say the common denominator. Common by, oops, I forgot the word though. By the common denominator. And I say common denominator versus like LCM is what I did before, and that makes more sense when they're numbers. Now your common denominator is going to have x in it, so it's not really a least common, still a least common multiple, it's just not as clear as what it was with numbers. Okay, so the example here, the only denominator I have is x minus 4, so if I was going to add these together, I would have to multiply all, this x by x minus 4 over x, whatever. So instead, I'm going to multiply my entire equation by x minus 4. Now that is one term, which is why I put it in parentheses. So when I distribute to my first one, I'd have x squared minus 4x. When I distribute to my second one, I would have the plus symbol from there, but then I would have x minus 4 over x minus 4. And then when I distribute to 0, I still get 0 on that. Now simplify each fraction. Okay, well that one was simplified already. Minus 4x. X minus 4 over x minus 4 does not disappear. It does not cancel. It's 1. Don't lose your ones. Like when we had 6 over 6, it wasn't 0, it was 1. Okay, now from here, okay, great. Now it doesn't have fractions anymore. You have to keep solving, and in this case, with it being a quadratic, nothing's going to multiply to 1 and add to negative 4, so I have to do my quadratic formula. So I'd have 4 plus or minus square root 16 minus 4 times 1 all over 2. Sorry, I should go a little bit here. Which would be 4 plus or minus the square root of 12 over 2. That is not a negative symbol, it's just an accidental mark. Okay. If we want to simplify, that square root of 12 is 4 times 3, and then the square root of 4 is 2, so this would be 4 plus or minus 2 square roots of 3 over 2, which then again would simplify to 2 plus or minus the square root of 3. Okay. Now, the one thing that does get added at the end here, or is one more thing we just need to be careful of, is something called extraneous roots. I'm going to say check for extraneous roots. Extraneous roots are, I'll say, answers that, I didn't want to put that line there. Here, move this. No, I can't move it. Okay. Sorry, answers that, I'll say, make a denominator equal 0. So because we cleared the fraction, you open yourself up to getting a number that, a solution, an answer that might actually, when you plug it back in, make the original denominator 0. Now, with being 2 plus or minus the square root of 3, those are not going to make this denominator 0. So this one does not have any extraneous roots. The next one we will to model that for you. So let's do another one and practice that. So if I were you, I would, when I'm done here, pause the video, see if you can come up with what your denominator, your common denominator would have been. So try it, put a number here, and then hit play and see if you're right, just to start practicing this process. So go ahead, hit pause, try it, and then hit play when you're ready. All right, for my common denominator, one thing that's going to make my life a lot easier is to factor. So if I have a quadratic, really it's going to be a quadratic. Maybe there's a cubic where you can factor an x out, but by factoring, I can see that my common denominator would be this whole thing, because this has the x plus 2, this has the x. And so x plus 2 is going to be what I distribute in, and that is significantly more, bigger of a term or an expression now than, multiplying 6 in. That's not super challenging. This is going to be, with it in this factored format, it is going to make it a lot easier to know what's going to cancel or divide to 1 versus keeping this x squared. That's just going to make things look even more challenging than they need to be. So let's model through this. So I multiply to my first one. So what I would have is x plus 2. Now I also have an x minus 3 all over x. Okay, go to my next term. So I would have 3x, x plus x. What's going on here? There we go. Plus 2 all over x plus 2. And then my third, I would have a 6x, x plus 2 all over, and I'm going to use that factor format again, and hopefully you're kind of seeing how that's helpful. Woo, sorry. And then when I distribute to 0, I just get 0. Okay, so we go to each term and we go, all right, what divides out? Well, x divided by x divides out. So x plus 2, x minus 3 is left. Sorry, my thing is. x plus 2 and x plus 2, those are exactly the same term, so I just have a 3x left. And this x divided by x is 1, x plus 2 over x plus 2, so just a 6 is left. Okay. And now it's a straight solving, so do a little foiling. X squared minus x minus 6 plus 3x plus 6. Did a little bit of fast math there. I combined terms as I went. So then I would have x squared plus 2x equals 0. Now I don't need to do a quadratic formula because this factors, which is wonderful. X plus 2 equals 0. Set each factor equal to 0. So x equals 0 and x equals negative 2 would be my solutions. But we have to check for extraneous roots. So when I go back up to my original, before I did any changing of anything, I notice, get a highlighter here, that if I put 0 in here, I get divided by 0. So that is actually an extraneous root. Now I check my negative 2, and I notice when I put negative 2 here, and really put them both there as well, that also gets a divide by 0. So this thing actually has no solutions, or no solution. Both of your zeros ended up being, or in this case zeros, ended up being extraneous roots. So yes, you have to write them, and so you need all this work, you write them here, and then you put a cross off, and I will know that that means you're saying it's an extraneous root. So then your solution is the words no solution. Okay, so again, just to reiterate, if you get to here and you're like, oh, it's not one, and you still have to write them, and then you cross them off, showing that it was a solution to this red part, basically, but according to my original, it did not work. Okay. All right, we will finish the rest of the notes, like I said, on Monday. This was just to get us rolling. We'll probably start with one of these just to make sure you are understanding and answer any questions or things that pop up. So thank you for watching. Thanks for taking notes. It was only 12 minutes here, so you've got the rest of the time to work on any old assignments, 2.5 or 2.6, for the rest of the time.